Today we'll take up question number 8 of December 19 and January 20 question paper. Question number 8a, what he asked is derive the torque equation of a DC motor with usual notations. He asked for the 6 mass that we have to see. That is, the torque is produced on a pulley if there is a force is exerted at a distance of r meters. Consider a pulley of a radius r meters as shown in the figure. I will show you the figure, acted upon by a circumferential force F newtons, which causes it to rotate at n rpm. When there is a force is exerted at the distance of r, there is a torque is producing, hence the pulley start rotating with a speed of n rpm. Therefore, the torque is defined as it is a product of force into distance, F into r Newton meter. Then what your interest is work done by this force in one revolution. In one revolution, just I will go through this first figure. I will show you the figure. This is how there is a figure. F is acted at a distance of r meter. Therefore, because of F into r, there is a torque is producing and it is rotating through n. For one revolution, what is the work done? Work done is nothing but force into distance. The force is F and the distance traveled in one revolution is 2 pi r, a total circumferential distance, that is 2 pi r, that is F into 2 pi r. Therefore, what is the time taken for one revolution? If it is the speed is n rpm, it is 60 by n second. It is very simple. The torque is, it is a product of force and distance, and the work done in one revolution is nothing but force into distance. Work done in one revolution is force is F acting, F is force is acting, and the circumferential distance of one revolution is 2 pi r. Therefore, it is 2 F pi r is the total work done in one revolution. The time taken for one revolution is, it is 60 by n second. Then I am defining what we mean by the power developed. Power developed is nothing but it is a work done per time you are considering for one revolution. What is the work done? F into 2 pi r. What is the time taken? It is 60 by n. Therefore, I am substituting here F into 2 pi r is the work done. The time taken is 60 by n. Then what I am getting is, I am rearranging the terms here, joining F and R, and 2 pi n by 60 is the equation. Here I am clubbing F and R because F into R gives the torque, 2 pi n by 60 gives the omega, that is angular velocity. Therefore, simply the power developed I express as the power deployed as T into omega, because F into R is T and 2 pi n by 60 is the omega. Then what is the actual electrical energy which is converted into mechanical energy? That is EB into I. That will show here. That is P is equal to T into omega, that you are derived already. Then the electric power which converted into mechanical energy is EB into I. EB into I. Therefore, P is equal to T into omega, and the power developed which converted into mechanical energy is EB into IA. Both are equal. Therefore, T omega is equal to EB into IA. At the same time, EB is 5Z and B by 60 into A. Then you have to find out what is the value of T. That is the T. What we are getting is T. We are transferring this omega to this side. Putting the value of omega is 2 pi n by 60 and substituting EB value as pi z n by 5 z n p by 60 into A. What I am getting is T is equal to 1.159 Zp by A into 5 into IA Newton meter. This is how you have to derive the torque equation. It is very simple. Start with the fundamental definition of the torque, F into R. Then you have to take for work done in one revolution. Then what is the time taken in one revolution? And you have to find out what is the power developed in one revolution, that is work done per unit time. You have to substitute, then P, what we are getting is T into omega. This P is nothing but the actual power, electrical power which converted into a mechanical energy that is given by EB into I. Therefore, EBI and T omega can be equated, so that what I am getting here is T omega is equal to EBIA. Then we are finding out the value of the T. This is how we have to derive the torque equation. Then question number 8A, 8B asks on 6-pole lap connected DC series motor. Is asked the DC series motor because field is connected in series with the armature, with the number of conductors 864, and the takes a current of 110 amperes at 480 volts. The armature resistance and series field resistance is given as 0.18 ohm and 0.02 ohm respectively. The flux per pole is also given 50 milliweber. I ask you to calculate the speed, the cross torque. You have to look into the data given here. Number of poles is 6. You have to list out here, given P is equal to 6. Lap connected, therefore A is equal to P. Then Z is equal to 864. And the current drawn from the line, what you are getting is 110 amperes. At the same time, series field current is also 110 amperes, and all armature current is also 110 amperes. Because it is a series motor, IL is equal to IA is equal to I series. Then applied voltage V is equal to 480 volts. Then he asks you to calculate the speed. The speed or a speed variable that is appearing in the back EMF equation, that is EB is equal to 5 Z NP by 60 into A. Therefore, our first step is to find out EB. Then how to find out the EB? Just the other data is RA and R series, and phi is also given. They ask N and TA. Therefore, first our intention is to find out EB. In the case of the series motor, the back EMF is equal to the applied voltage V minus IARA minus IAR series. That is another drop you have to adding here, that is series resistance drop, that is IA into R series. Therefore, the back EMF EB is equal to not V minus IARA. In the case of series motor, it is V minus IARA minus I into I series. Therefore, can substitute all the values are given, that is V is 480 volts, that is given, and IA, I told you in the case of series machine, IA is equal to IL is equal to 110 amperes because it is a series motor. Therefore, your IA is equal to 110 into resistance is 0.18. Similarly, IA into R series or I series into R series, that is I series also is equal to IL is equal to IA, that is 110 only. Therefore, 110 into 0.002. Therefore, what we are getting is 450 volts is the back EMF. Once we know the back EMF, then you can find out what is the speed by the equation EB is equal to 5 Z NP by 60 into A, that is EB. Therefore, from that you are finding out the N is equal to, because EB is equal to 5 Z NP by 60 into A. From that I have to find out the value of N, transferring 60 into A into this side and 5 ZP in the denominator on the other side. Therefore, I am establishing the relation for the speed here. Then all the data are known, just you have to substitute in this. Then what we are getting here is the speed of the DC series motor, 636 RPM is the speed. Then also you ask the gross torque, that is the gross torque. How you are finding out? You have to make use of the formula, that is TA is equal to 0.159 ZP by A, phi into I. Z is given, then P is also given, the number of parallel bars, it is a lap connected, P is equal to A, phi is also given, and IA is also given, that is 110 amperes. Just you have to substitute the values here, then you have to find out the torque, that is 755.5668 Newton meter is the torque, that is the armature torque what we are producing. It is very simple. The first step in the motor, this one is you have to find out the back EMF. In turn, from the back EMF, you have to find out the speed. And the torque equation we know directly. In that, all the data are given, just you have to substitute and you have to get the value of the torque in terms of Newton meter. Then question number C, what he asked is derive the EMF equation of a DC generator. It is asked for a 7 marks. Here first you have to list out what are the nomenclature you are using in the EMF equation. That is, flux per pole is 5 webers, number of poles is P, the speed is n rpm, the number of conductors is Z, number of parallel paths is A. These are nomenclature you are using 5, P's, N, Z and A. Then how there is the induced voltage? According to Faraday's laws of electromagnetic induction. Magnitude of induced EMF is given by a rate of change of flux. That is a basic the law of induced voltage. The flux cut by a single conductor. I am considering a single conductor where in one revolution, what is the flux cut by? That what I am calling is a d5. If it is rotating through one revolution, there are p number of poles, each pole producing the flux of 5 webers. Therefore, the total flux cut is p into 5. Then the time taken for one single revolution is 60 by n because the speed is n rpm. Therefore, the voltage E can be calculated as d5 by dt according to the Faraday's laws of electromagnetic induction. The d5 here is p5 and time is 60 by n, just I am substituting here. Then after simplification what we are getting is p5n by 60 is the induced voltage. It is the induced voltage in a single conductor. There are such Z number of conductors are there. We have got A number of parallel paths. Therefore, effective conductors per parallel path is Z by A. Therefore, if you are multiplying Z by A to this equation, you are getting the induced voltage in a Z number of conductors with A number of parallel paths. Therefore, what I am getting here is 5Z NP by 60 into A volts. That is, for lap winding A is equal to P, for wave winding A is equal to 2. This is how you have to derive the equation. You have to nomenclature, you have to give clearly. Then on what principles you are deriving the EMF equation, that you have to write. That is a Faraday's second law that gives the magnitude of induced voltage, that is d5 by dt. Then you consider single conductor for a single revolution. Then what is the flux cut in a single revolution, you have to find out. Then what is the time taken for a single revolution. Then you have to find out what is the induced voltage. This is how you have to derive the EMF equation. In the next session we will take up the module number 5, question number 9.